is reflected. Okay, so the I can look at the intensity of the reflection is equal to the intensity reflection coefficient times the intensity that's arriving there, which was I1. Okay, and so it's going to be equal to this number, 0.0100794 times 73.451 milliwatts per square centimeter. Okay, so if I look at that on the calculator, I have 0.01079 times 73.45. Okay, so that's equal to 0.7928193. And that's still milliwatts per square centimeter. Now remember that the intensity transmission coefficient is equal to the intensity of the transmission is going to be, remember the transmission coefficient is equal to 1 minus the reflection coefficient. And so actually I could just take the difference between these two values and determine the transmission, or I could take 1 minus the IRC, which is, so let's do it that way. So if I take 1 minus 0.010794, that's equal to 0.98926, and I'm going to be multiplying by my other number, the intensity of the wave incident at that interface, 73.45 milliwatts per square centimeter. So times 73.45, enter, and so that comes out to be just 72.657 milliwatts per square centimeter. So only a small amount of the wave is reflected, 0.792 milliwatts, and a large amount is transmitted, 72.657 milliwatts transmitted. Okay, but we aren't done yet. So by the time we want to look at, the next thing we're going to look at is how much this wave will be, this reflected intensity is attenuated by the time it gets back to the transducer. Then the transducer can pick it up and analyze the reflection. Okay, and so it's already down to this amount, and it turns out we already calculated the so we're starting with a reflection of 0.7928193 milliwatts per square centimeter, but we're going to attenuate the same amount as when it passed through here. So it's going to, when it goes back up, it's going to attenuate the same amount. So I multiply by 0.07345, the amount that it's attenuated, and so let's do that. 0.7928 1 times 0.07345. Enter. Okay, and so that comes out to be equal to 0.0582 milliwatts per square centimeter. So the reflected intensity that's finally received at the transducer from that interface, which I called I2, I believe. Yes, I2 is 0.0582 milliwatts. So that's all that's left for I2. Okay, and the last thing I wanted to do was to calculate I3, what would be the intensity after passing through that muscle tissue. Now this one has a much larger intensity coefficient of 3.3 decibels, and it's a little further, so it's 4 centimeters. Okay, so let's take a look at that. Okay, so first of all, the attenuation through the muscle is 3.3 decibels per centimeter per megahertz, and then it's 4 centimeters is the distance I'm traveling through that muscle tissue times 6 megahertz frequency. And so let's take a look at that. So it's 3.3 times 4 centimeters times 6, and that's equal to 79.2 decibels of attenuation. Or I could look at this if I plug that into to figure out how much that is. I have to take let's see, this 10 to the 79.2 divided by 10, and since it's attenuation, that has to be negative, and so that's equal to 10 to the minus 7.92. That's going to be a really small number. So if I do 10 to the 7.92 power, that's, oops, sorry, I need to go negative. Try that again. 10 to the negative 7.92 power. There we go. That comes out to be 1.20226 times 10 to the minus 8th power. And if I multiply that by the transmitted intensity, which came out to be transmitted was 72.657. .657 milliwatts. Per square centimeter. My intensity number 3 will then be equal to 8.735 times 10 to the minus 7th power milliwatts per square centimeter. So very little intensity is left by the time the sound gets to the other side of that muscle tissue.